Good morning, good afternoon, good evening, ladies and gentlemen. Thank you for joining the UNEP OzonAction side event at the 32nd meeting of parties to the Montreal Protocol. As a housekeeping announcement, kindly know that all participants are automatically muted. Please use the question and answer chat box at the bottom of your screen to post your question to the speakers, which will be addressed at the end of the session. The question will come at the end of the event. This session is recorded and will be posted on UNEP OzonAction webpage and on YouTube channel. I will hand over now to Mr. Jim Kerlin, Acting Head of UNEP OzonAction Program, who will introduce and moderate today's event. Jim, the floor is yours.
Thank you, Ayman. Ladies and gentlemen, good morning, good afternoon, or good evening to you, and welcome to UNEP OzonAction's side event on this first day of the 32nd meeting of the parties to the Montreal Protocol. We're pleased to organize this webinar in cooperation with 4 of our key international partners: ASHRAE, the European Association of Refrigeration, Air Conditioning and Heat Pump Contractors, AREA, the Indian Society of Heating, Refrigeration and Air Conditioning Engineers, ISHRE, and the China Refrigeration and Air Conditioning Industry Association, CRAA. So we're very thankful to them for agreeing to share their rich knowledge and their expertise in this sector during today's session. As part of UNEP's role as an implementing agency of the Multilateral Fund, OzonAction strengthens the capacity of governments in developing countries to enable them to meet and sustain their compliance obligations under the Montreal Protocol. A central part of this work is to support the refrigeration and air conditioning servicing sector in developing countries through training and certification of technicians and operators about good servicing practices and reducing refrigerant emissions. Now, ladies and gentlemen, since we met in Rome at the 31st meeting of the parties, the Montreal Protocol family has not been able to meet in person for 1 full year, which is the first time that this has happened since the start of the protocol 33 years ago. The global COVID-19 pandemic has been posing many challenges for the entire Montreal Protocol community at the international, regional, and national levels. All of our institutions, operations, and personnel have been affected in one way or another. In spite of this daunting situation, however, we need to continue helping developing countries to maintain their pace of activities and their programs to enable compliance with the protocol while observing the health guidelines related to COVID-19. Since the refrigeration and air conditioning sector is at the heart of the Montreal Protocol, we need to pay particular attention to managing the impact of COVID-19 and learning to live with the virus. The RAC sector plays an important role in the battle against COVID-19. Now, on one hand, air conditioning is at the forefront of managing indoor air quality, or what is now being called indoor environmental quality, where the control of airborne viruses is critical in minimizing the spread of the disease. On the other hand, the cold chain sector is moving to the forefront as a crucial element in securing the success of the upcoming global vaccination campaign that aims to reach every corner of the earth. Meanwhile, countries still need to ensure the business continuity of their refrigeration servicing sector so that they can continue meeting their obligations under the Montreal Protocol. Now, ladies and gentlemen, the Montreal Protocol, through the robust multilateral fund that has been operating successfully since 1991, it's the only international treaty that addresses the needs of the refrigeration and air conditioning servicing sector in terms of good practices and sound management of refrigerants. The multilateral fund continues to provide a tremendous level of financial and technical assistance to developing countries to enable them to comply with this treaty. And that includes training, certification, updating of local standards and codes, building the capacities of the technicians and the operators, and promoting recovery, recycling, and reclamation. Now, with this in mind, it is critically important now that we ensure that this type of support also includes COVID-19 considerations. After all, the safety of the building operators, the servicing technicians, and the public that uses these buildings should always come first. So this brings us to today's session, which is entitled Installing, Operating, and Servicing Air Conditionings in the Time of COVID-19. So we've noticed at UNEP that there's been a lot of information in the media over the past few months about the role of air conditioning in either spreading or curbing COVID-19. So accordingly, in this session today, we wanted to give you access to the knowledge of key international associations that represent industry and the professionals in the refrigeration and air conditioning community, with the aim of demystifying the subject and offering you their guidance. So with that brief introduction, I would like to now turn to our first speaker. Our first speaker is Professor William Banfleth, who is the chair of ASHRAE's Epidemic Task Force. Dr. Banfleth is a professor of architectural engineering at the Pennsylvania State University in University Park, Pennsylvania. Now, he's a past president of ASHRAE in the 2013-2014 period, and he's served in various capacities with the society over the years. Dr. Banfleth is also a member of the American Society of Mechanical Engineers and the International Society for Indoor Air Quality and Climate. So, Dr. Banfleth, we're honored with your presence, and we sincerely appreciate that you've joined us despite the very early morning hours at your location. So, with that introduction, I turn it over to you, please. Thank you.
All right, thank you, Jim, and I'm very glad to be with you today. My task here is to give everyone a brief overview of engineering controls for airborne infection risk. In other words, the things that we can do with HVAC systems to reduce the probability of infection. We'll start with just a little bit of review of fundamentals. I think everyone's aware that there are different modes by which infectious diseases can be transmitted. One of them is through the air, either by larger droplets that don't stay suspended for a long time, or by aerosols that can stay in the air for a long time. And then there's also intermediate surface or fomite transfer and direct contact. These three are all important in COVID-19 transmission. And then there are other modes that relate to other diseases, vehicle-borne diseases in water, food, and blood, and vector-borne insects and animals, but they don't really relate to the topic today. And HVAC systems principally affect aerosol transmission, so that's what we're going to focus on in this talk. So where do infectious aerosols come from? Humans are the main source that we're concerned about. Anytime we're exhaling, whether it's breathing, talking, singing, coughing, sneezing, we're producing a lot of fine droplets of various sizes, as you can see in the visualization on the right. Plumbing fixtures can also produce aerosols that may be infectious, and that's actually been a factor in some of the coronavirus outbreaks in the past, the original SARS outbreak, and recently it seems perhaps also in COVID-19. And then finally, there are medical procedures that can produce droplets, but we're focusing on the human-generated aerosols. If we're going to control them, we need to know some of the properties of those aerosols. The figure on the right on this slide shows a distribution of sizes of droplets produced by respiratory activity. So we see here distributions of size versus a number versus size for speaking and coughing, and we see that they're similar, and this is true of other activities as well. What differs between them is the number of droplets produced. What you can see from this figure is that the most likely droplet size is somewhere down around 1 or 2 microns, and most of the droplets are smaller than 10 microns. And pathogens may be in any of these droplets and the particles that result from their desiccation. They're going to dry to 20 to 40% of their initial size. More than half of the viral load can be in particles that are smaller than 5 microns, and they can stay in the air for a long time. So that's both a risk, and it's also the key to controlling them. Fairly recently, the Centers for Disease Control and Prevention in the US and the World Health Organization have made statements recognizing the possibility of indoor airborne transmission, which it took a long time to get them to make, but now everyone seems to agree that this is a significant risk. The CDC has three main statements about infection risk. One, that close contact is still believed to be the most common method of spread, and that fomite transmission may occur, but that under some circumstances, SARS-CoV-2 can be transmitted in enclosed spaces when there's prolonged exposure and when there's inadequate ventilation and air handling. So this relates directly to how HVAC systems are designed and operated in buildings. Because there are these multiple modes of transmission, HVAC systems can only mitigate a part of the total risk. The risk management hierarchy of controls is shown on the right-hand side in this figure, and you can see that in order of importance, elimination of sources is the most important. And after that, when we're considering an infectious disease hazard, engineering controls are the next most important because they're the means by which we reduce exposures. In addition to that, there are administrative controls and personal protective equipment, which have figured prominently in public health recommendations related to the pandemic, distancing and requirements to wear masks, and also the masks themselves. They're generally less effective because there are a lot of ways for those controls to fail or to only be partially effective. The controls that we'll talk about I've broken into 4 different categories: ventilation, air distribution, filtration, and activation. And I've split that up into 2 subcategories: air cleaners and control of humidity and temperature. These are all much discussed as potential controls for COVID-19. Now, ventilation with outdoor air is our main control for indoor air quality for all sorts of contaminants. We exhaust contaminated air that's picked up contaminants from indoor sources, and we replace it with cleaner, we hope, outdoor air. It's effective but very energy intensive, and of course the suggestions that outdoor air should be increased substantially in buildings has created a lot of anxiety that this is really going to have a negative effect in the short term and perhaps in the long term on energy use of buildings if it becomes embedded in standards. ASHRAE's current recommendation is simply to ensure that the minimum ventilation rate that should be provided is occurring because there are other controls that can be used. This is partly in response to this concern about energy. So that means generally 7 to 10 liters per second per person or 15 to 20 cubic feet per minute per person, depending on your preferred unit system. As we can see in the figure from a study that was done in dormitories at Tianjin University in China a number of years ago, there was a very clear relationship between the winter ventilation rate, as it varied from a low but almost acceptable 5.2 liters per second per person down to 1.3 liters per second per person, an effect on the incidence of colds amongst the residents of those dormitories. And that's the sort of thing that happens when we don't ventilate a building properly. Air distribution has some impact on transmission of infection. We've seen cases, as in the Guangzhou restaurant case study that's been widely discussed, where strong drafts created by HVAC equipment determine where infectious aerosols move. So we should avoid that. On the other hand, in terms of air distribution strategy, it seems that perhaps mixing without strong air currents is the best way to do it, based on studies that have shown that stratified ventilation systems can fail from that point of view. And we may use local exhaust or personal ventilation in some cases to control risk as well. But in most buildings, there isn't much we can do about this. So I think this is more of a matter that's going to be important in considering design of facilities in the future. Filtration removes particles from the air. Some call it mechanical filtration, and mechanical filters can be quite effective on particles the size of these respiratory aerosols. In order for a filter to be effective for removing an infectious aerosol, it's got to recirculate air inside the system. Reducing recirculation, which has been a recommendation from some quarters, actually makes it harder for filters to do their job, because the important thing is the product of the efficiency of a filter and the recirculated flow rate through it. The filters that are required by minimum standards are not very effective against respiratory aerosol-sized particles. ASHRAE standards specify MERV 6 or MERV 8 filters. You can see the efficiency versus particle size of typical MERV filters in the figure. They're not effective at all for particles down there in the 0.5 to 5 micron range that we're concerned about. So upgrading to MERV 13, which would be about the equivalent of an EPM1 50% filter, is what's being recommended. And when central filtration can't be upgraded sufficiently, standalone HEPA filters can also be added. Air cleaners are a means of inactivation, so they don't actually remove the aerosol from the air, but they do something to it to make it no longer infectious. One of the main ways of doing this is with germicidal ultraviolet light, which is a very well demonstrated technology. It damages the DNA and RNA of pathogens or their outer envelope. The Centers for Disease Control in the US has approved it for many years for tuberculosis control, and there are multiple ways to use it in buildings and in spaces, as shown in the lower left figure, in an upper room configuration where there's a disinfection zone above the occupied zone that can give the equivalent of 10 air changes per hour, or airstream disinfection where it may be in an air handling unit. There are other less proven technologies, mainly ones that put reactive oxygen species into the air. Ionizers, dry hydrogen peroxide, and photocatalytic oxidation are three of those. There's some evidence for the effectiveness of these, but also some indications that it may be uncertain at times, and there are some concerns about health effects as well. So if they're going to be used, the evidence needs to be clear that the particular technology is both effective and safe in the application. The other kind of inactivation is temperature and humidity, and this has been the subject of a lot of discussion in the US and elsewhere. It's been shown by some research done by, for example, the Department of Homeland Security in the US, that the activity and life of viruses is affected by both temperature and humidity. And there's also research that has suggested that humidity affects human susceptibility to infection. So there have been suggestions that it's very important to maintain a certain humidity range. Generally, that's 40 to 60% relative humidity. But there's research such as that done by Lindsay Marr at Virginia Tech that indicates that although there may be a significant effect on inactivation of relative humidity, it's not necessarily a strong effect when combined with other controls. So in the figure we see on the right-hand side here, I've circled in the 1 air change per hour figure the variation of inactivation with relative humidity as it goes from 10% to 90%. You can see that that's quite significant, but when that inactivation is put together with ventilation and settling, we see that there isn't a very strong relative humidity effect overall. So we don't consider this, or at least ASHRAE does not consider this to be a first order control, although if your building is humidified, that's a good thing, but adding humidity is not necessarily something that is recommended. So a summary comparison quickly of the controls. Ventilation is limited by temperature and humidity control constraints to how far we can go with it. It's expensive, it has a low first cost impact, but also a big energy impact. Filter upgrades are limited by flow resistance effects in existing systems, and they may increase fan energy use a bit. Variable first cost impact, but very effective overall. And air cleaners, there's a wide range of cost and performance. They don't affect comfort, which is a good thing, and they have moderate to low energy use and cost. So they all reduce exposure. The question is, how do you combine them, which is the topic of a different talk. So to conclude here, these controls that we've just discussed reduce risk by reducing exposure by various means: dilution, capture, and activation. They have a significant range of effectiveness, energy use, and cost. It's important to understand that our minimum ventilation and filtration requirements for non-healthcare facilities are not sufficient to provide good risk reduction relative to COVID-19, so we need to do something about it. And to get the best outcome, we need some optimum combination of these controls that allows us to meet our risk reduction targets, but also other concerns that have to do with cost and energy use. And finally, air cleaners are an important class of controls, but there's quite a bit of uncertainty about how well they work, and we need to be careful in applying them. So that's my brief summary, and I'll leave you here on my last slide with the URL for ASHRAE's COVID-19 guidance, ashrae.org/COVID-19, where you can find a lot more information than I've been able to present here in this brief talk. Thank you.
Thank you very much, William. And it was a very interesting presentation, and I particularly was interested in the hierarchy of controls, which showed where engineering controls fit in the big scheme of things. So thank you for that overview to sort of set the scene. So we'll move now to our next speaker, Mr. Graham Fox, who is a director at AREA, the European Association. Mr. Fox is a chartered engineer with over 30 years experience as an industry leader in the field of building services engineering. He is a fellow of the UK Institute of Refrigeration and a member of the board and a past president of AREA. He's also a member of the Chartered Institutes of Building Services Engineer. And thank you, Graham. Thank you for joining us today, and we look forward to your presentation. So the floor is yours. Graham, you're muted, I believe.
Apologies. My when I went to share my screen, it took my ability to unmute myself away. Can you hear me now?
Yes, we can.
Right. Okay. Let me try and share that screen again. Oh, Iman, can you make me the presenter again, please, so I can share my screen?
You are now.
Thank you. Okay, let's try that again. Okay, apologies for that, everyone. So yeah, thank you for the invitation to speak today. I am, as Jim says, a director of AREA, the European Air Conditioning Refrigeration Contractors Association, and I represent the UK Contractors Association, the BESA, at AREA. We developed guidance for our members at the BESA in the UK back in late February, as the crisis was developing, mostly centered on handling filters and access to air handling units and things like that, how to prevent transmission via fan coil units, and trying to explain the emerging evidence that was coming out from the restaurant incident in China that had become quite well known, because our members were getting a lot of inquiries from their clients, and they were asking us for advice. What we did at AREA was we developed that guidance from the UK and made it a bit more pan-European to suit the European market. And we developed the guidance that I've just put the header of the guidance sheet on the screen for you, for your information. This was based on guidance that was coming out from REVA, CIBC, ASHRAE, and in response to CDC, World Health Organization, and medical journal research papers. And as I say, our aim was just to try and provide best advice and good practice guidance for our members. A lot of the guidance that's out can be very, very technical, very, very kind of academic speaking. And what we find is that our members, who are the actual contractors on the ground, often are turned off by that kind of language, and they need quite clear and simple messaging. So what we try and do is strip that back and give very practical guidance on how to actually address whatever issue it is that they're looking at. This particular guidance is available in English, Spanish, Italian, Greek, and Polish for those who are interested. In the UK, as I say, our members were facing daily calls from clients asking if systems can be used or couldn't be used. There were conflicting reports in the media, and a lot of scare stories being propagated by the media about the safety or otherwise of using air conditioning units in particular. So we developed this to try and address those concerns. The BISA guidance has evolved even further in the UK, and we do need to actually update the AREA guidance that we have on the AREA website. The most up-to-date version is in the link that you can find there, and as Bill said, for the ashray.org/COVID-19, we have the same thing, the bisa.com/COVID-19, with a dedicated section all about guidance on COVID, practical guidance such as this, but also lots of advice for employers and building users and all kinds of stuff. So what we've done as this guidance has evolved is we actually developed a risk assessment and flow decision chart to help our members' clients decide whether they can actually safely use their occupied buildings. So it could be office spaces, it could be bars, restaurants, cinemas. And it was to try and help them understand how they can mitigate risk and allow those public buildings to be put back to use again, albeit with limited numbers due to social distancing requirements. To give you an indication of where we were coming from on this, a typical public space, such as a bar, this was depicted from an article in El País on the 28th of October. There was a really good article in their online newspaper about how the virus can be transmitted with and without mitigating engineering solutions. So what this diagram here shows is that with there's a high number of fellow patrons will be exposed to a virus by one infected person being in that room if there are no mitigating measures taken. Basically, without any ventilation introducing fresh air or air conditioning treating the air in circulation, then the viral load becomes so concentrated that there is virtually no chance of avoiding infection. Now, the exposure may be low and the risk of being seriously ill may be low from this level of exposure. That is for epidemiologists to debate. Our position as experts in the air conditioning and ventilation sector is to advise on how our systems integrate into buildings and affect the airflows. That same bar with good ventilation now being introduced, that will dilute that viral load and massively reduce the exposure of the patrons. Thus, you'll see a huge reduction on passive infection rates. The changes of air in the occupied space are crucial in reducing that risk of exposure. We also know that as humidity levels drop, then particles in the air can travel further due to them being lighter. So it is also crucial to consider the humidity levels, airflows, discharge grill locations, and the locations of people in the occupied space in relation to the discharge or return grills. Now, to give you a little bit more of an understanding on what I'm saying about the discharge flows, when we look closer at the discharge airflows, we can see that an infected person sitting in that air throw, then every breath out is releasing contaminated particles into the air, which can be then blown directly across the room into the path of non-infected people in that occupied space. Enough exposure over a period of time with no ventilation to dilute that viral load, and the risk of passing on or infecting others will naturally grow. And with return grills on air conditioning systems or exhaust grills in larger ventilation systems, for example, you have a similar issue where potentially contaminated air can be drawn back past non-infected people with the risk of infecting them. And so the cycle continues. So this is why it's critical that we think about air direction, air flows, air throw off a unit, velocity of the air throw, and the reach of that air, and then where people are located in rooms in relation to that air distribution. So as I said at the beginning, what we developed at the BESA and the COVID guidance was we incorporated a point of work risk assessment, which is designed to enable our members to properly assess the risks of not only each site, but also each zone on a site. A company's corporate premises will have several zones with very different uses and possibly different systems installed in each zone. So it's important to assess each zone in its own right as a separate entity to properly assess the risks in that zone. And the first thing we're asking is, have you measured the ventilation rate in the zone? There's little point in demanding a minimum flow rate if you don't know what you have in that room already. In the grey guidelines box out section, we've highlighted that CIBSE Guide A, so CIBSE is the Chartered Institute of Building Service Engineers. In the UK, CIBSE is the main writer of building standards and codes of practice. So CIBSE Guide A is a UK design guide for non-residential buildings. And in that, they suggest a 10 litres per second per person ventilation supply. But that to mitigate against COVID, we are recommending in our guidance that the building managers, building operators, are aiming for at least double that rate currently to reduce the viral load. So what the risk assessment does is it makes the contractor think about what the actual rate currently is, so that they can then properly determine if it is sufficient as it is, or if additional measures need to be put in place. An interesting consideration, for example, is that a ventilation system may be designed for the normal 10 litres per second per person under normal circumstances, but that with the current social distancing restrictions that are in place, particularly we find in office spaces in the UK here, that actually, because you've effectively reduced the number of people using that office, then you might actually already be getting near enough that 20 litres per second target without any additional equipment or additional measures being put in place. And again, unless you're actually risk assessing that zone properly, then you're not really understanding if that's an issue or not. Next, we're looking at the seating plans, as I said, to take into account the discharge and airflow direction that I've just talked about. We also consider if the fan coil unit is actually necessary for the introduction of fresh air to the space. So some fan coils are locally recirculating, but others are essential for the introduction of outside air or fresh air, or just the dispersal of the fresh air. We have a number of buildings where, for example, the fan coil is actually introducing fresh air into the room, but it's on one side of the room. And if that fan coil isn't actually running, then that fresh air isn't getting distributed across the room. So that's really critical. So that fan coil clearly needs to be running. And finally, we have sign-off after remedial actions have been taken to address any concerns or hazards raised in Section 2. These risk assessments have been widely used in the UK in recent months for local government, schools, offices, shops, to provide peace of mind that risks have been properly considered and addressed, allowing the building to be used again. We are now developing in the BESA group a Clean Air in Buildings certification scheme in the UK to give the public peace of mind that the indoor air quality or indoor environment quality, as Bill alluded to earlier, in public buildings has been properly dealt with, to encourage them to return to shops, bars, restaurants, cinemas, etc., to get the economy kick-started again, because that's really what we're needing to address. So with that, that's my very quick overview. I will pass back to Jim.
Graham, thank you very much for that presentation. I noted the importance of translating very technical guidance into or technical information to practical guidance for the practitioners, and the risk assessment approach to ultimately to issue certification for public buildings to reassure the public so that economic activity can return in a safe way. So all of that is very interesting. Thank you very much for the presentation. So I think we'll move now to the next presenter. It's time to sort of shift the compass to address now in-field practice. And I would like to welcome Mr. Vishal Kapoor, who is the chair of the COVID-19 task force at ISHRAE. Mr. Kapoor has engaged with the HVAC industry for the last 24 years. He has served as the ISHRAE national president during the 2017-2018 term, and he is currently the national chair for the ISHRAE Technical Committee. He's the chair of the ISHRAE COVID Task Force, the vice president of the Indoor Environmental Quality Global Alliance, and he's a chair of ISHRAE International Advocacy and a vice president of ASHRAE East India Chapter. So with that introduction, I turn it over to Vishal. Thank you.
Thank you, Jim. Thank you very much. Greetings to everyone from all across the world. And it's a pleasure being out here. Is my screen visible?
Yes, it is.
Okay.
Perfect. Oops, there.
Yeah, I hope it's all clear.
Yes, please.
Okay, thank you. So greetings from India and from ISHRAE, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, of which I am right now the technical chair and taking care of the COVID task force. It is a large society. We have around 43 chapters all over the country and more than 24,000 odd members, including students. And we represent everything technical as a society made of individual members, whether it's from technical content or research, skill development, education and certification, and variety of other activities which keep us closely linked to the HVAC in our industry and everyone who's a stakeholder as part of this. Similar to a lot of other societies across the world, a lot of associations who have worked in the last few months dedicatedly on COVID and the role of air conditioning and ventilation on how to mitigate and reduce the effects. ISHRAE also did its bit starting very early in the month of March when the effects started coming into the country also. And we, in the process, brought out a lot of documents. You can see this, they're all available as free downloads on our website, ishrae.in. And documents like the COVID-19 guidelines document for air conditioning and ventilation. We also brought out a very important guidebook on startup and operation of the systems during pandemic, because a lot of systems were shut down and we had lockdown for going from 2 months to 4 months. And when offices started opening up, there were a lot of other problems that would need to be taken care of. And those were only handled from there. We also worked with the Medical Society of India, the medical IMA, HPI, which is the medical association of the country, because healthcare workers are at the forefront of this entire fight. And we worked with them as to how are they supposed to operate their systems to control the spread of this disease in the healthcare facilities. Because in the early days, there were a lot of virus being spread, a lot of infections being spread in the hospitals because everybody wasn't aware as to how to handle the whole situation. We worked along with them. Apart from some documents, a lot of training were done for various operators across the country on specific on healthcare facilities. So we did a lot of work on this sphere, and the book that the guidance document we brought out talks about indoor environmental conditions, it talks about various kinds of applications, and most importantly, it talks about operation, maintenance, and startup. The predecessors before me have covered very well on things like in the environmental conditions and various applications, so I won't be spending too much time on that. I'm going to be looking on the more of the practical side of the business, because in our country, it's a very, very varied application, and we have all kinds of systems being used across residential and commercial facilities. So we wanted to make it very, very simple for people to understand what they're supposed to do and what not. It's us as engineers, as people, practitioners from the industry, we can understand the technology and the science behind it. But people who are actually using it or operating it would not be able to make much of that, but they would want more practical inputs, and that's what we restricted ourselves to. So starting first, this is our a room air conditioner is something which is very, very popular in our country. It's got very, very high penetration levels across the entire geographical reach of the country. We are primarily a country which needs cooling more than we need heating. In very, very few parts of the country we need heating. Bulk is all cooling, and room air conditioner is a very fast growing segment, and people were scared in the initial days what to do with room air conditioners, can we operate them or not? And we brought out things saying that yes, you can operate them, but with some very strict conditions. Whereas basically we do not want to be restricting the room only to recirculation. Now, please understand, we're talking right now over here about residential applications. So we're not talking about multiple occupants. You're talking about one, maybe two people in those residences, in that room where you have this air conditioner. So we said recirculation should always be accompanied by bringing in some amount of outdoor air. If you can do it through a fan filter unit, perfect. Otherwise, at least with open windows, it would be good than nothing else. We also recommended to have humidity levels set between 40 and 70, though you cannot set humidity levels in this, but at least you can monitor and ensure that's being taken care of, and take your temperatures beyond 24, maybe go to 26, 27, so that it's better for the virus not to spread. Another one very important product that's available in our country is something called as evaporative coolers. It must be there in the rest of the world also, primarily for process or the manufacturing sector. In our country, it's very, very popular in the residential sector. And a lot of our country is dry and warm, hot. And this cooler, we also call them popularly a desert cooler, do the work very well because they can actually take the temperature up to 15 degrees cooler than the outdoor air. And that's very, very comfortable. And obviously, it's a very low energy application because it's basically just a pump and fans working. So again, we had some protocols over there that the windows must be kept open to release humid air. We do not recommend recirculation. We want air to come into the cooler and then be thrown out from the other end so that we're creating a proper path of movement of this air. A fantastic product because it's bringing in literally 100% outdoor air. It's not recirculating, which is fantastic for COVID times specifically. We also talked about hygiene. You need to keep the tanks clean, disinfected, etc. And if possible, add a filter because we could then prevent dust entry into the room from outside. A lot of our country still does not have air conditioners, or even if you have air conditioners, they use fans for a lot of time in the daytime to save on the power cost, etc. We also talked about that if you're running a fan, it would be very nice to keep the windows partly open. If you have an adjoining room like a toilet which has an exhaust fan, it's good to keep that fan running mode always because that creates a path for outdoor air to come into the room and get out so the room stays very well circulated and ventilated. Now, when we come to commercial facilities, when you look at commercial facilities, there are primarily three stakeholders in any commercial building. You have the occupants, you have the owner of the building, and you have the facility managers or the service providers, as you would call them. The biggest challenge in commercial facilities is that they would have multiple occupants and occupants coming from all over the place, and you would not be able to know who is who otherwise, and monitoring them is not so easy at all times. So when you look at the three stakeholders, the occupants, owners, and the facility managers, what is it that occupants of that office, whether it's a small or a large office, need to look at? It's things which are very easily known to us, from self-assessment to masks, to distancing, hygiene, try and work from home if it's possible, as much as possible. So it's occupants themselves who start the whole process of ensuring that they are not spreading or getting infected with this virus. Then we come on to the owners, and we've had both speakers speak before me on engineering controls, on ventilation, on filtration, as three of the most important aspects which can be taken care of. So in existing buildings, wherever the owners of the building can take care of providing all these three and increasing the possibilities of better ventilation, better filtration would obviously help. I would spend a little bit extra time on what should service providers and facility managers be doing. And you have risk assessment, and Graham talked very well before me. They need to ensure the screening and distancing norms are being maintained, maintain the hygiene services, isolation facilities, and ensure, most importantly, that the MEP services, operations, and maintenance are as per the protocol. Specifically coming to the HVAC equipment, they need to have the proper operating guidelines, which we're talking about right now. They need to ensure that they monitor and measure. It's not just what you install or just what you are taking care of on day one. You need to continuously monitoring and measuring the performance of what you've installed. A very strict protocol for maintenance. A very, very proper procedure for startup after a lockdown, when offices or other facilities would open after long lockdowns. And very importantly, In fact, we consider that one of the most important aspects is service team safety and health. When you look at the commercial facilities on a filtration, we're talking about upgrading to the MERV 13 kind of a filter if it's possible. If the system can take the load of a MERV 13 filter, try and go towards that side. In case you cannot upgrade a filter if the machine, the AHU does not have the necessarily static to take care of additional pressure drops, you can then install and operate standalone purifiers, at least, and very, very clearly with HEPA filters. It's also been recommended to install a UVGI system in the HU air path, and very important, you maintain and clean, replace filters as per protocol, follow the process carefully, and keep a checklist ready, reckoner, so that you know when was the last maintenance activity carried out. We then talked about ventilation. Now, ventilation, especially outdoor ventilation, does come at a high energy cost, and everybody wants to save on energy, save on operating costs at all times. But in these times, health and safety is far more important than just trying to save energy cost. So we have very clearly said that we need to ensure mechanical ventilation for outdoor air. Please understand, a lot of installations do not have mechanical ways of bringing in outdoor air. They just have kind of a louver on the building facade, which is kinds of bringing in the outdoor air because of negative suction. But we have said no, please pressurize, bring in it through a fan or if possible, a treated fresh air unit. Check the air quantities that you're bringing in from outside and try and maximize the outdoor air. Bill talked about the quantities, about the CFM rating that as occupants should be having inside in office, and our numbers are pretty much the same as what Ashtray and Bill talked about. Our book talks about the same thing. We also said that you can monitor the CO2 levels inside those occupied spaces. That's one very clear way of knowing that are you bringing in adequate outdoor air into your premises or not. The service providers should operate the toilet and pantry ventilations at least 2 hours before opening and after office closing, so that you keep the place very well ventilated. In very exceptional cases, for very, very small commercial offices, small offices having 2 to 10 people in those places, if for some reason you're not able to have a mechanical system, you could then look at least operating your windows and keeping them partly open, even at the cost of your temperatures inside the space going up a little bit, but at least you are providing outdoor air. When we look at other things were on the indoor unit coils. You need to ensure that they are always clean, check the conditions. If possible, monitor and measure the pressure drop or the air quantity across the coil so that you know that the quality of the coil is perfectly fine or not. Condensate drain pan, again, check the condition and the cleanliness. If possible, install a UVGI system for continuous disinfection. We've talked about the temperature and the RH conditions. Ensure that those are monitored very well. You can measure RH and temperatures very easily in all offices. Do that because that will help you understand whether the system is operating properly or not. Air distribution patterns have been talked about, and a lot of studies have happened in that, and that is playing a very important role in controlling the spread of virus from persons X to person Y. Post-lockdown, when a new office or an office which has been shut down for 2 months or 6 months or 4 months is opening, there are some protocols that need to be followed because your office could be in trouble, not just because of the pandemic or because of the virus, but otherwise also. So apart from sanitization, we've talked about the fresh air and exhaust system. Try and check in advance whether you can modify the system and maximize your ventilation and filtration accordingly. Ensure that all parts with the air is touching, whether filters or grills, the drain pan, the coils are all clean, disinfected. We've also talked about that in case the area has ducted air distribution, it's advisable to clean the ducts, including sanitization. Cooling tower is a very important issue to be taken care of because stagnant water is absolutely a big, big problem, and they need to be cleaned and disinfected very properly. There are clear protocols available how to clean a cooling tower before putting it back on, specifically when it's being shut down for a long time and it will have stagnant water inside. We've talked about in our book, in our guidelines, that when you're restarting an office, there are a kind of a checklist given out there as to how you take the whole protocol. And it's not that you just put the air conditioning on and invite the occupants to start working in their office. You've got to follow a particular fashion where you run the fresh air system as at the maximum possible setting. You run the exhaust systems as much as possible. And then you run the air conditioning only in fan mode. Then you run it in the normal mode. And after those few hours, when you've done enough ventilation, it's literally like a building flush out. and then you allow the space to be occupied. As I mentioned before, the fresh air and the ventilation system should be kept on throughout the off-cycle and weekends, holidays in air circulation mode to ensure continuous ventilation of the premises even when it is not occupied. I talked about we putting a lot of stress on service staff, safety first, and we've brought out in our document very clear guidelines for our service technicians, and we do continuous training, hand-holding in different languages for our service teams across the whole country as to what they're supposed to do. Obviously, the first thing that starts it is a PPE. It's very important for technicians because they are moving into multiple offices, multiple residences, coming across different kinds of systems which they need to operate, they need to maintain. So we as people, as the industry practitioners, need to ensure that their safety has been taken care of very properly. Travel, we have suggested that if they can avoid public transport, it's very nice. People traveling in two-wheelers, motorbikes, or scooters, it's advisable to have one person per two-wheeler and not more than that. One of the most important thing for a service technician is how they handle the filters, and PPE was mandatory while handling filters. Do not touch the media of the filter, handled by the frame only. If it's a washable type, it cannot be cleaned inside the HU room. It has to be bagged up very properly, sealed in those bags, and taken to a pre-identified wash area before you clean or dispose. Ensure cleaning protocols are followed by the manufacturer and the kind of filter that you're using, and before refixing, it's totally dried up. And please remember, all filters are not cleanable. In fact, most are not cleanable because they are to be changed. We talk about limiting the interaction with occupants or movements into window spaces. There are technicians which would normally be walking into offices, taking measurements multiple times a day, checking things. We want that to be as limited as possible so they do not come in touch with the occupants of those spaces. Do not share your instruments, do not share the PPE, stationery, etc. Each person for himself carrying all these things. You clean and disinfect your tools from side to side. Always carry disposable bags for PPEs. Do not use alcohol-based sanitizers when you're working with electrical sources because that can be very dangerous. So that's where, bringing to my last slide, where we talked a lot about how to operate, how to service, how to ensure the safety of our technicians, of our operators, of our service providers, and ensure that they are absolutely safe. We are operating the systems as much as per protocol as possible because we need to operate buildings, we need to occupy buildings, and at the same time ensure that we are taking care of all the norms. Thank you very much.
Thank you very much, Mr. Kapoor, for the very interesting presentation. I note throughout the practical nature of the guidance that that ISHRAE is giving, and that there is it needs to be tuned to the type of equipment, the type of installation, and the nature of the application. So it's clear that ISHRAE has thought through very carefully on these different steps for the different commercial, residential applications, and it's very interesting guidance. So thank you for sharing that. We appreciate that. Thank you, sir.
Thank you, Jim. Thank you very much.
Last but not least, I'd like to welcome Dr. Baolong Wang, who is the vice director of the Clean Room Committee of CRAA. So Dr. Wang is an associate professor serving in the Department of Building Science of Tsinghua University. Currently, Dr. Wang serves as the secretary of the E1 Commission of International Institute of Refrigeration and chairman of the IIR's working group on dehumidification in air conditioning. Dr. Wang is a member of the Technical Advisory Group of the International Organization for Standardization, ISO TC86 SC4, and he's also General Secretary of the Technical Committee in the Chinese Association of Refrigeration. Now, before I give the floor to Dr. Wang, I'd like to kindly remind all participants that we will be starting the Q&A session after this presentation. So kindly send your questions through the Q&A box and try to make your questions as short as possible. So concise. So Dr. Wang, the floor is yours.
Thank you, Jim. Firstly, thank you, all of you, for inviting me here to introduce some work we have done on the COVID-19 transmission research and some guidelines we have developed by the CRAA. The topic of my presentation is the operation strategy of air conditioning system in public buildings, especially in public buildings during this pandemic time. As you know, there are several ways for this virus transmission. So besides the contact, the droplet aerosol transmission is a very important way for this virus transmission. Because the droplet and the aerosol transmission is transmitted by the air. So any air sharing system, such as the air conditioning system, is a potential tube for cross-infection. So the operation strategy for air conditioning system in public buildings should be carefully plotted before operation during a pandemic. In the second part, I just like to show we have do some infection risk analysis for this virus in public buildings. In this calculation of evaluation, actually, we used this simulation method. Actually, there are many similar research, but in here, we try to show maybe more visible method. In this simulation, maybe we use Rayleigh equations. It's widely used in evaluate the infection probability. Also, the difference in our simulation, we used the safety method to simulate the non-uniform distribution of the indoor air. And I'm not to introduce all the parameters, but I like to say that in this simulation, we only one infector. So if there are many infectors, so the possibility may be increased largely. There are two scenarios in our research. One is this scenario, just like this figure on the page. What's the infection possibility if there is one infector in the room? What's the infection possibility for the persons in the same room? Actually, for the public buildings, there are two kind of air conditioning system, just like the right one. It's we call that the all air system, which means that the fresh air mixed with the return air in the air handling unit and supply into the room. After that, the air is exhausted to the ambient, and part of it return to the ambient, return to the air handling unit. Another one we call that the vacuum unit and the fresh air, and the VRV and the fresh air. The difference that in this VRV or vacuum unit and the fresh air system, there's no air go back to the supply air. So we can find some very important solution. First one is the influence of the distance. As we all know that the distance that is a very important factor in affecting the infection possibility. No matter you just at the front of the infector or just besides the not just at the front, but after the other directions. No matter which direction, you can see the distance is very important. So keep space is a very important thing for avoiding the infection. Another thing, I think the clean air volume. I think this factor has been mentioned by William in previous presentation. Yes, it's the clean air volume maybe lead to more academic definitions actually, but you can understand we considering the outdoor fresh air and clean air. So by use the fresh air, fresh air, you can see the infection possibility can be largely decreased, maybe from 30% to lower than 10%. But another thing I think is very interesting for because if you do, before you read this research, maybe you don't agree with that. By use purifier, by use air cleaner or air purifier, you can make the return air, you can make the circulated air more clear. So by this method, you can also largely decrease the infection possibility. So it's very important because for this Fanco unit of VRV system, you don't have too much you don't have very large air handling unit of the fan tubes, so you cannot supply a very large amount of fresh air goes into the room. But which means that in this room you also can use the air purifier or air cleaner to keep the infection possibility low. Very important result. Another thing about the influence of the mask. So from this figure, you can see that by wearing the mask, the risk can be largely reduced. So another scenario is this, just like this figure. One air handling unit supply air to multiple rooms, but only one room there are some infectors. So how about the persons in other rooms? So we analyze this situation. This figure just shows you the infection possibility. No matter how much for fresh air you used, if there is no return air, the FA means fresh air, RA means return air. If there's no return air for the person, if there's no return air for the person in other rooms, they are all very safe, no infection possibility. That's very important. But if you use the return air, so there are some infection possibilities. So that's why in all of the guidelines for operating the central air conditioning system, they forbidden to use the return air. Another thing is very important, even in that kind of system with the return air, but you wear some mask, the infection possibility can also be very low. So according to previous research, we can found some very preliminary results. For the rooms with infector, many measures can be used to decrease the infection probability, including keeping space, using fresh air, outdoor air, open window, using air purifier, and so on. But the probability cannot be decreased to zero. For rooms without infector but sharing air conditioning system with other rooms, low return air system, make sure no infection. For Fanco unit of VRV system and fresh air system, the medium to high efficiency filter should be added into the Fanco unit or VRV terminal. Mask is a very cheap and effective way for avoiding infection. So based on that, the different departments in China issued several guidelines for operation air conditioning system during the pandemic. For example, the state council issued the guidelines for operation and managing air conditioning and ventilation system in office and public building. And CRA, Chinese Association of Refrigeration, also published recommendations for safety use air conditioning heating system in response to COVID-19 after the Spring Festival holiday. Today, I want to introduce one of the guidelines issued by the China Refrigeration and Air Conditioning Industry Association. These guidelines, the following for this guideline is guidelines for evaluation and operation, disinfection and maintenance on refrigeration and air conditioning during work resumption under the COVID-19 epidemic. In these guidelines, the process to restart the air conditioning or heating system, including following 4 parts. First one is the system evaluation. Second step is sterilization and disinfection. The third step is review of emergency plan, and the fourth one is precautions for operation and maintenance. In the system evaluation, actually there are 2 steps. First one, the function of the air conditioning system will be evaluated. In this evaluated, there are many questions should be asked and also answered. Whether the air conditioning system can switch to the operation mode conforming to the epidemic control standard, including whether the fresh air change rates meet the requirements of the standard, whether the system can operate in the all fresh air mode, whether the polluted air can be isolated and operated independently, whether the relative pressure of the polluted area can be maintained, whether there is a potential of the cross-infection. Actually, in this part, it's very important because if even you use all fresh air system, but if the intake port of the fresh air is quite close to the exhaust port of the exhaust air, so there are also some probability for cross-infection. Another question is whether the system has automatic disinfection function. The second step for the evaluation is the hygiene evaluation. I will not go very detailed in that. The second step is the sterilization and the disinfection. It's suggests that all the HVAC system should be sterilized and disinfected before restart. And all this disinfection or sterilization should strictly follow the specification for different type of the HVAC system and cold chain system. Because actually, maybe you know that China meets the situation in 2003 for the SARS. So actually, we have built a lot of code for disinfection and sterilization. So all these process must follow those standards. The third part is the review of the emergency plan. In the emergency plan, or the following question of the problem must be solved if virus cases is founded. So how to quickly report it to the decision maker, whether shut down the system or switch to another operation mode. Technicians must be proficient in the system isolation, fresh air adjustment, and negative pressure control. And for the hospitals, the attention should be paid more to the exhaust air handling. The final step, the precaution for operation and maintenance. First one, the personal protection is very important for the technicians. And the technician also should do the daily reports very strictly. So I want to say that the building air conditioning and ventilation system play an important role in prevention and control of the epidemic. The central air conditioning system has a low risk when it is properly operated. Operation strategy and the emergency plan should be carefully prepared. Thank you.
Thank you very much, Dr. Wang, for that interesting presentation. So I learned about the importance of the numerical simulation and probability calculations for designing the subsequent steps that those who own and operate equipment need to follow. And it was, I see that China has developed I would say, a wealth of guidelines for air conditioning during the pandemic that is based on this type of sort of scientific analysis of the situation. And as you said, the proper operation of central air conditioning systems can be done safely if one follows the correct technical guidance as you have described. So thank you very much for the presentation. I think we will now move to the question and answer session, and we've received a good many questions, and we'll try to accommodate as many as time allows. And I apologize in advance if we can't address all the questions, but we'll make sure to coordinate with the experts to respond to all of the questions offline if we can't handle them. I'd like to ask all of the speakers to please turn on their cameras as we respond to the questions. So if you could turn on your cameras, please. And I think the first question that we've received was from Zia Islam, who is the National Ozone Officer of Pakistan. And this question is from Mr. Kapoor. He says, thanks for a very informative and useful presentation. I shall be interested to know if the recommendations and guidelines from ISHRAE are mandatory or voluntary for the domestic and commercial sector. So Mr. Kapoor, please.
Thanks, Zia. It's a good question. Primarily, it's all voluntary, though the guidelines that were brought out by ISHRAE were adapted by the government of India for the government-occupied buildings where we have the public utility departments, and they had attached our guidelines as mandatory for those buildings. But outside the government-owned buildings, these are basically voluntary guidelines. And what we're doing is that we're working a lot very closely with various other stakeholders. For example, the facility management associations of the country, the companies across the country have been following our guidelines, and the protocol are part of their own internal systems, though being voluntary, but they are being taken care of to a large extent.
Okay, thank you for that. Thank you for that response. The next question is for Mr. Fox. With the detailed risk assessment and mitigation measures offered by industry and professional associations, are these measures comprehensive and mature enough to be incorporated into the national codes of practice and the certification programs, or are we still at the learning phase? So, Mr. Fox?
That's an interesting question. I mean, obviously they've been developed over a period of about 2 months now, and they were derived directly from point of work risk assessments that were developed by the Institute of Refrigeration about 1.5 years ago. So they're derived from well-established risk assessment templates. What we've done with it is we've stripped out a lot of the work method parts of a risk assessment, just to focus strictly on the actual zone itself, because obviously we're trying to just risk assess a specific issue at the moment with that. We are currently working on a number of additional guides within the BESA group in the UK to clearly define indoor air quality, what it actually means. We are bringing out a layman's guide, because what the problem is that we as professionals can often talk about all these things, and we'll talk about particulate matter and VOCs and humidity, and it actually means very, very little to 90% of the population. So that there's little point in us developing indoor air quality guidance when most of the population won't understand what we're talking about. So we are bringing out a layman's guide to really simplify that for the general public. That in conjunction with the guidance we've already got, and developing risk assessments into the kind of clean air building guidance that we are currently developing will become, we think, in the UK the standard. But there is also a best practice guidance that is currently being developed by BSI in the UK as well, PAS 3003 it's called, and this will tie in with this is kind of the practical application of that standard. That answers the question.
Great, thank you very much. The next question is for Dr. Banfleth. It is expected that once the pandemic situation is cleared, relaxed attitudes concerning mitigation measures will be the case. How critical and which mitigation measures are needed for the post-COVID-19 era? So, Dr. Banfleth?
Yeah, thank you. And I assume we're talking about controls. Obviously, I think distancing and masks are going to be relaxed. But in terms of what happens to HVAC systems in the future, I would expect that filter upgrades could stay in place, because a MERV 13 filter actually has a lot of general indoor air quality benefits. The particulate matter that it captures is itself a major public health problem. And World Health Organization has estimated 8 million people die from PM exposure per year, excess mortality. So that's already becoming a standard in some buildings. Whether there'll be more ventilation, I don't know, but it certainly seems like it might be a good idea. I think what we'll see primarily is starting to look at infection control as a criterion for indoor air quality in buildings that are not healthcare facilities. And you can see now the difference between a hospital standard and a commercial building standard. So we may see some of those practices move over to other types of new buildings.
Great, thank you very much. Next question is for Dr. Wang. Do you think that the mitigation measures would be different when servicing indoor versus outdoor units? Would you like me to repeat?
Yeah. Could you repeat the question?
Do you think mitigation measures would be different when servicing indoor units versus outdoor units? So mitigation measures for indoor versus outdoor units.
In my mind, what I mean the mitigation method.
So what type of let's say safety measures is the approach for servicing indoor units quite different from servicing outdoor units? Presumably, they will be different conditions because of the open air.
Okay.
And
thank you. Actually, that should be different. Actually, I remember one of the presenters talked about that for the indoor unit, actually, if you do the disinfection, so there are many methods we can do that. But for the outdoor units, actually, maybe not so urgent to do that, but it's much difficult.
Okay, thank you. Actually, a follow-up, slightly different question, but also for you, Dr. Wang.
Yeah.
And this is coming from the ozone officer from Colombia. And the person says, is it possible to share the guidelines that China has developed? It would be very much appreciated.
I think there's no problem, because actually after this meeting, we will share the PowerPoint file through the net, so you can find the link, so you can download those guidelines. But I should say that the teams, just like Jim said, actually in this presentation, I just show you how we simulate that, how we decide the guidelines. But actually, I think we just show you how to do that. Actually, the guidelines, actually, they have some measure to do steps, 2 different steps. Actually, they have more comprehensive consideration than my simulation.
Okay, so I think in general, probably for all of the participants, the idea of having making some of the materials that they had mentioned accessible, we will try to on the OzonAction meeting portal, where we will post the presentations. We will also have links to whatever the panelists have indicated as resources. So anything for pointing for additional information, we will put on that site. So thank you very much. Okay, there's actually a question that came twice that I was kind of saving towards the end because it's a little bit slightly off topic, but I think it's of high interest to everyone. Can any of the panelists give an idea of the confidence that we have in the let's say the air filtration system on airplanes, the air conditioning, air handling on airplanes with regard to COVID? So if any of you would be willing to volunteer for that.
Well, aircraft have very high air change rates, for one thing. It can be over 30 air changes per hour, and the air is HEPA filtered in aircraft. So from the point of removing particles from the air, I think those systems are pretty efficient. The main concern on aircraft, I believe, still remains short-range contact. We saw in the figure that was shown by Dr. Wong earlier that the probability of infection goes up a great deal. And even when you don't have people in the middle seat, the passengers are not very far apart. So that's my view of it.
Yeah, the other issue about that is when you're sitting on the plane and people are boarding. We all know that people put their hand on the back of the chair, and I think the biggest issue is surface contact and surface contamination. Still, certainly when I flew a 4.5 hour flight a couple of months ago, and I wasn't concerned about the air quality. I was concerned about the contact surface. And the first thing I did before I sat down on my seat was I sprayed disinfectant all over the seat and the handles and the tray table, which I didn't use, but I still sprayed it down anyway.
Those used to be the crazy people.
Yeah, I know, right? Yeah, so maybe it still is, Bill. Maybe it still is.
Excellent. Yeah. So those are fomites, I think, that you're referring to, Graham. So,
yes.
And the good thing is that sanitizers and things can take care of a lot of that, or avoiding to touch them in the first place.
Exactly.
And it's reassuring to hear that the high air exchange rate is the systems work. It's more how the people within airplanes, I would say, interact with one another, or the proximity of the people. That's probably the determining factor. Okay, we still have a minute or two if other questions are coming in from any of the audience. So please submit a question. I actually had one question for you, Graham. You spoke about this sort of detailed risk assessment approach that was being done in the UK, and if I understood correctly, applied through AREA at a wider field. Has this actually been applied in real life situations? I know risk assessment is a tool, but are practitioners are using this and applying it to real world situations, saying, I have this large restaurant, this is the airflow, the patterns coming in, it passes through this part of the restaurant, it goes out the other path. What is,
Yeah.
Or is it more of a theoretical exercise at this stage?
No, I know mainly schools have been using it in the UK when at the end of the summer, when the education authorities were looking to reopen the schools after the summer vacation break. A lot of the local authorities were actually using the risk assessment to risk assess classrooms and schools, and particular things like canteen areas, common areas within schools and things like that. So I know it was used quite a lot by local authorities when it first came out. I know it's also been used certainly by local authorities in some of the office buildings that the local councils use and things like that. And I know that there's one of the large insurance underwriters as well, actually went back to one of the local authorities, I think it was in Wales, and asked specifically of the school building officer, are you applying the BISA guidelines? So it is being used in practice, which is good to know. it wasn't a fruitless exercise in developing all.
Okay, thank you very much for that. Thanks a lot. Okay, I think we're approaching the end of the time, and the meeting will start soon. I mean, the reason we at UNEP are involved in this discussion is, as I said at the beginning, developing countries need to ensure the business continuity of their refrigeration and air conditioning systems. First, to comply with the Montreal Protocol. That's where where we're coming from, our angle. The rack systems, these systems, as we have heard, are also crucial for restarting the economy. They're an essential part of our national economies, and if they don't work, the economy doesn't work. And ultimately, the refrigeration air conditioning professionals, the technicians, the people on the ground, the building owners, all of them have to adjust to these type of COVID-19 requirements that we have heard in today's presentations. And we've heard excellent presentations from different angles, and it shows that the associations and professionals working in this field are taking it extremely seriously, that have already developed a wealth of guidance that have already rolled it out in their countries and in some cases in their regions. But it's now up to the rest of the world to start thinking along the same lines and also organizing their industries to be looking at these things like risk assessment, about airflow, about how the systems are maintained, how all of the points that were touched on by our four excellent presenters. So this is the challenge in front of us under the world, but under the Montreal Protocol, and we have to somehow incorporate this into our work henceforth. So I guess at the end of this event, now that we're at the end, on behalf of UNEP, I would like to express our sincere appreciation to today's speakers, to Dr. Banfleth, to Mr. Fox, Mr. Kapoor, Dr. Wang, and their partner institutions, ASHRAE, AREA, ISHRAE, and CRAA. But most importantly, I'd like to thank all of you for attending, all of the audience, and I hope that this event was up to your expectation. This will not be the last event that we have in relation to COVID-19, unfortunately, and we will keep everyone posted about future events. We've been recording this session. We will put the recording and the materials available on our website and on our YouTube channel. We do apologize for some who could not join because of some technical problems with links to join the session. We will make sure that we share with you, with all of those people, the recording presentations of the event. So for those attending the 32nd meeting of the parties, we wish you a good meeting, and for everyone to stay safe, to have an excellent day, evening, or night, wherever you are. Please wear a mask, socially distance, and wash your hands. Follow the guidelines, as we've heard. So thank you all very much. Thank you in particular to the four presenters. Thank you.
Thank you, Jim.
Thank you.
The session will end now. Thank you so much to all.
Thank you.
Bye.
Bye-bye.